Hello, and welcome to the Suite Solutions webinar on Advanced XPath. My name is Ruben Weiser. I work for Suite Solutions, and I'll be spending about an hour showing you the ins and outs of some intermediate and advanced XPath techniques. We'll start from the beginning and work our way up for those of you who may not be as experienced. I'd just like to preface with two elements. First of all, you may notice that I've changed the title a little bit from simply Advanced XPath to Advanced XPath and XSLT. That's because XPath and XSLT, which I'll explain soon exactly what they are and what the distinction is between them, are really inextricably combined, and you can't really have one without the other. So anything that you do advanced with one will require the other, so we'll be looking at both of them. The other thing that I'd like to mention is that XPath is really extremely wide-ranging. There is a lot going on. There's a lot to learn. I'll show you later a reference link on the web that you can look up, and if you follow that link, you'll see that there's a lot of information there. So we certainly won't be learning everything today. I won't even be able to give a comprehensive overview because there's simply too much. But what I will be doing is showing you some techniques, some examples that will allow you to at least know how to go about using some of the more advanced capabilities of XPath, as well as learn more on your own from the links that I provide. And it'll give you a taste of what XPath is capable of. It's surprising exactly how advanced it is and how far it's come. So let's get started. First of all, who am I? As I mentioned, my name is Ruben Weiser. I work for Suite Solutions for about 2 years now. I have a background in computer science and informal education. I've worked for a number of different computer companies over the past decade, working on such items as web applications, client-server applications, and now obviously focusing on XML publication, style sheets, CMS integration, elements like that. As a member of the Suite Solutions team, I've also worked on some both on-site and online training seminars. My focus, generally speaking, is PDF and HTML style sheet projects, so XPath is really something that I work with every single day. I also work a lot with CMS integration, specifically integrating the DITA-OT and the custom style sheets into our different clients' CMSs, making sure that they're able to publish through them, as well as some more general project management responsibilities. Suite Solutions, for those of you who may not know, is a small company whose goal it is to increase our customers' profitability by significantly improving the efficiency of their information development and delivery processes. That's basically an official way of saying that we help you manage your information, and by doing that, we hope that we do help you increase your efficiency and thereby your profitability. We provide a content lifecycle implementation, which is an approach to your entire lifecycle management from the very beginning of the concept all the way down to the publication, making sure that we're with you every step of the way so that you can get the most out of your time and our time. Let's get started. Just for a quick overview of what we'll be discussing, first we'll start off discussing simply what is XPath. We'll start off with some of the basics just to review the foundation, the fundamentals of XPath, how it's structured and how it works. And then we'll get into some increasingly complex and advanced examples, starting with some list numbering, trademark showing the current function, showing how to implement custom functions, giving an example of the Tokenize function, discussing keys, and then getting a little bit further into what keys are capable of with some grouping examples. Some of these examples you'll see actually consist of two examples, an old way and a new way. You may know that XPath has a version 1.0 and a version 2.0. Version 2.0 often makes things significantly easier, but some of you may be limited in being able to use only version 1.0 depending on the version of the DITA-OT that you use. So we'll see two ways of doing some of those, and you can choose whichever one is most appropriate for your needs. First of all, what is XPath? XPath is an XML path language. It basically provides a way to navigate an XML tree. XML is obviously structured as a tree. You have a parent node, child nodes, those children have children, those children have children, and so on. So there's a whole structure going on there. And XPath provides a way, if your current node is a particular node in that tree, to navigate upwards and downwards and search through the tree for other values. And it provides a way to select and manipulate particular nodes or values. It's useful in that when we're processing XML, we often need to retrieve information that's not sitting right in front of us. We may be looking at a title, but how we want to render that title may depend on the type of topic that we're sitting in. So in order to navigate, so to speak, from the title to look at the type of topic that it's sitting in, we need to look upwards in the tree. How we process the title may depend on the contents of the topic, what sort of elements it has, and therefore we need to look downwards into the contents of the topic. Those are simple examples. XPath provides more complex capabilities as well. There is a basic tutorial at the link that you see in front of you, www.w3schools.com/XPath. But for more comprehensive reference, you can go to the w3.org site, which basically has the entire spec laid out there. XPath 1.0 was first put out there, published in November 1999, and you can see the complete comprehensive reference for that at the link that you see in front of you. XPath 2.0 excuse me, has been out since January in 2007. It is available in versions of the DITA-OT since version 1.5. And therefore, any of you using DITA-OT from 1.5 on are able to make use of the new capabilities of XPath 2.0. Any of you working before that will be limited to the capabilities of XPath 1.0. If you follow those links that you see there, you'll see that there's a lot going on. As I mentioned before, there's a lot of information. It's really a very long web page, and there's a lot to learn. But let's get started on some of the basics, working our way up to the intermediate and advanced, and then you can use those references as references for anything that you want to research further. The basic syntax of XPath, as you probably know already, is what you see in front of you: axis, colon, node, and then brackets, predicate. What that basically indicates, looking at an example, in order to look, if you're sitting in a topic and you want to look at all the children nodes that are titles, you would, for example, say child, colon, star, open brackets, contains, @class, quotes, topic/title, close quotes. Basically what that means is looking at the children, that's what the axis there indicates. It sort of shows us the direction in which we want XPath to look. Looking at the children, find for us any node, that's what the asterisk indicates, any node, whose, that's what the brackets are for, it's a predicate, for which it is the case that the class attribute contains the string topic/title. Contains here is a function. The @ indicates the class is the attribute, and then we're looking for any class attribute, any element, any node, where the class attribute contains the string topic/title, i.e. it is a title. That's the basic syntax, and really everything that we're going to see is simply an expansion of that. An axis, a node, a predicate, probably a function, and we'll see exactly how that structure can be expanded on to achieve increasingly complex and sophisticated results. To look at a real example, here's an actual example from the commons.xsl file that processes figures. What you see here is we have a template, and here you already see the very close interconnection between XSLT and XPath. All of the light blue parts, XSL template, XSL apply templates, those are XSLT. All of the brown parts, or almost all of the brown parts, the longer ones, are XPath. So XSLT makes use of XPath, and in some cases we'll see XPath actually makes use of XSLT when you use functions. But what we see here is we have a template that matches, again, asterisk means any node, for which it is the case that the class attribute contains topic/fig, i.e. it matches any figure. And then within that, we first apply templates, i.e. we process any node for which it is not the case that its class attribute contains the string topic title, i.e. any non-title elements, whether that be an image or a list or a paragraph or a table, whatever else is included in that figure. And then finally, we process any node for which it is the case that its class attribute contains topic/title. i.e. the title. And this is a way of making sure that when we process the figure, whatever order the elements are within that figure itself, first we process everything that's not the title, and then we have the title on the bottom. That's the default, and obviously in order to change that order and have the title on the top, you would simply need to change the order of these two lines. Those are basic examples. Let's discuss some of the concepts that we've seen. We spoke about the axis, the direction in which XPath should be instructed to look. So here's the short list of XPath axes. The first one itself, which instructs XPath to look simply at the node itself. Attribute is looking at an attribute of a node. Child is what that sounds like, or parent. Following means anything in the entire document following this node, whereas following sibling means a sibling of this node that follows it. It obviously wouldn't look at something 5 topics later. The same is true for preceding and preceding sibling. Preceding is anything in the document that precedes this element, whether that be, looking at it in the final PDF, whether it would be something that would end up being 2 lines before or 20 pages before, that would all be included in preceding. Whereas preceding sibling is simply siblings that precede this one. So if you have 5 list items and you're looking at the 3rd list item, then the first 2 list items would be preceding siblings. Ancestor looks at any ancestor of the current node. Ancestor itself looks at any ancestor of the current node or the current node itself. The opposite is true for descendant. It looks all the way down into all of the descendants of this node or all of the descendants starting with itself. Namespace looks at the namespace of the current node. That's generally not used all that much. And then just to discuss some XPath abbreviations, simply having text refers to the name of the current node. A slash selects from the current node moving downwards, whereas a slash selects from the current node, or if there is no current node, starting from the very top of the document, searching comprehensively down through all descendants, anywhere in the node. Dot selects the current node, that's the same as saying self. Dot selects the parent of the current node, that's the same as saying parent. The @ sign, as we saw previously, selects an attribute of the current node. The asterisk is a wildcard, it matches any node. The node matches, again, any node of any kind, whether that be a text or a processing instruction. And then the brackets, as we spoke about, contain a predicate, which is used to sort of put certain conditions, certain filters on what sorts of nodes we'd be looking for. It's used to set conditions, and we'll see a lot of those as we go forward. That concludes our discussion of the basic infrastructure, the groundwork for XPath. Let's start going forward now into some increasingly complex and advanced examples to see how we can build upon that infrastructure to achieve more complex results. The first example we'll look at has to do with list numbering. The goal that we have is that a client has a number of ordered lists, but they want most of their ordered lists to be numbered, 1, 2, 3, 4. But if there's an ordered list in a figure, then rather than numbers, it should have letters, capital letters, A, B, C, D. And if there's a sublist, specifically an ordered list within an ordered list, then the top level list should have 1, 2, 3, 4, but the sublist should be lettered, but this time with lowercase letters, A, B, C, D. And we can achieve that. I'm obviously not giving the greater context here exactly where this fits in because we're focusing here on the XPath, but you can see that we can achieve that by formatting our number based on certain conditions. So we have a choose statement, which is basically a case statement with 3 possibilities. When the condition is true, and if there's a condition that doesn't seem to set a specific condition, there's no equals or greater than or less than, that means that it's really simply testing for the existence of such an element. So what we're looking for here is when there exists such an element along the ancestor axis. That means we're looking towards the ancestors of the current node being the ordered list, or the list item. When there is, looking towards the ancestors, any node whose class attribute contains the string topic/fig, then we know that we're currently sitting within a figure. If there's an ancestor of our current node that's a figure, then we're within the figure. And in such a case, use a number formatted as a capital A, and that'll give us A, B, C, D, all capitalized. If that's not the case, but if we count all the ancestors where the class contains the string topic/OL, and that count is greater than 1. Again, here I'll emphasize that really this code is sitting within a particular list item. For each list item, we assign a number. So if we're in a top-level list, that list item will have one ancestor that's an ordered list. But if there's another ordered list above that ordered list, i.e. if the count is greater than 1, the count is 2 or more, then we know that our current list item is not within a top-level list, but rather is within a sublist, a subordered list. And therefore, we're going to put in a number that's formatted as a lowercase a, b, c, d. And again, here we see another function, simply count. Ancestor that starting from, let's get my mouse working here, starting from ancestor through till the closing brackets will return the entire set of nodes that match that. And therefore, count will count all of the nodes that match that XPath query. If that count is greater than 1, then we'll use lowercase letters. Otherwise, if neither of those are true, then we simply move on to the default, which is to use simple letters. Simple numbers, not letters at all. So here we're getting a little bit more complex using some of the other axes that we saw, adding in a function of count in order to more heavily conditionalize our output. One note on technique. You may have noticed and wondered why we keep using this contains method, this contains function, where the class contains topic/fig. We could just as easily say, in a default case, we could say when test equals ancestor : fig, rather than match all nodes whose class contains topic/fig. Why don't we just match fig nodes? In most cases, these are functionally equivalent. However, it wouldn't account for specialization. If we were to specialize the figure element, the fig element, and then assuming we wanted the same behavior, that any list within our specialized fig element also has capitalized letters, then our specialized fig, let's say we call it my fig, will not be a fig element. It will be a my fig element. And therefore, the latter example that you see here would no longer match it because the specialized element has a different name. However, the class attribute, as you hopefully know, the class attribute in DITA-OT contains the full hierarchy of specialization. And therefore, if we were to specialize fig into an element named myfig, the class attribute would contain topic/fig space, whatever we decided to call it, topic/myfig. And therefore, it would contain both of those class elements, and this first example would continue to match it, whereas this second example would no longer match it because the name of our element had changed. So again, in some cases, these are functionally equivalent, but going with the first option, this contains class topic/fig, is really the more flexible of the two, and in most cases is what you want to use to keep the flexibility that you'll get with specialization. If you look at the default DITA-OT code, it almost always uses this contains class. Very rarely goes simply for the direct element name, as you see in the second example here. That's it for our first example, list numbering. Let's move on to something slightly more complex, a trademark example. The goal here is that a client wants the trademark symbol to appear only on the first usage of each trademark. In DITA, there's a TM element. It has a trademark attribute that indicates the text that is being trademarked. And by default, the result of that element is that it puts a little TM in superscript after your text, or a little registered trademark symbol after your text, depending on some of the other attributes that you say. If you have a particular trademark term used numerous times throughout your document, you may want the little trademark symbol to appear only on the first usage. But because of the flexibility of DITA and the reuse of concepts, the reuse of topics, you may not know for any given document which usage is the first. So the best practice is to put the TM element around all usages of the term and then customize the style sheets to ensure that only the first instance gets that little symbol that you see there. How is that done? So here again, we'll look at two examples. Right, so we'll look at two examples. The first example that we see first gets the trademark attribute of this element. In order to compare this TM element to all previous elements, we need to compare their trademark attributes. So we first need to get the trademark attribute of our current element. We set that to be this variable, XSL variable name is trademark, and we get the trademark attribute of our current TM element. And then we check to see if there are any previous elements that have that same trademark attribute. We do that by seeing if it is not the case that there is a preceding element of any kind whose class contains the text topic/TM, i.e. it is a TM element, but again we're checking using this contains method, and the trademark attribute of that element is equal to this variable that we previously set, which is the trademark attribute of our current element. We had to set this variable from our current trademark attribute because once we're inside the predicate, we're looking not at our current node, but rather at the node that we're examining in the predicate, the ones that are caught by this asterisk over here. So obviously we couldn't say @trademark equals @trademark. They would both be the same thing. So we need to say that the trademark attribute of this element that we're looking at here, namely the preceding one, is equal to the trademark attribute of our current element, which we have stored here temporarily as a variable. So if it's not the case, there's a preceding element that has the same trademark value, then we're going to process this TM and put in the symbol and so on. I've omitted that code because it's not relevant to our current example. The point is that we limit our processing in that we'll only process the symbol if there is no preceding element with the same trademark attribute. Now, I had to give that whole explanation of the variable and this trademark attribute and that trademark attribute because once we're inside these brackets, once we're inside the predicate, we're looking at the node that's matched by the star, the preceding element. Starting with XPath 2.0, which again is incorporated into Ditto 1.5 and on, there's an easier way to do that. Most of it's the same. We can leave out the variable, and when we get to the comparison here, we simply look at the trademark attribute of the preceding element and check whether it is equal to the trademark attribute of the current element. This new method here, current, open parentheses, close parentheses, is new, and it gives a way to quickly and easily refer to the current element regardless of where you are in your XPath. So even though we're inside the predicate, current still refers to our current trademark element. And therefore what we're checking here is if it's not the case that there's a preceding element that is a trademark and that preceding element's trademark attribute is equal to the current element's trademark attribute. It gives us the same result as the preceding solution, solution 1, but it does it slightly more concisely and I would say perhaps also more readably. Your variable may not always be right there on the line before. So this is really an easier way to refer to your current element's attributes. These are two ways to approach this problem. A little bit later on, we'll see another one that comes from the use of keys. That concludes our trademark example. Let's now look at an example of how to define custom functions. The goal here, it looks like I missed a word, a client wants to convert certain text strings to title case. There are certain elements, let's say button names or titles, that authors have entered in lowercase or uppercase or some combination, and perhaps under certain circumstances that the client wants to change the capitalization of those strings to be title case. Specifically, the first letter of each word is capitalized, and all the following letters of each word are to be lowercase. How can we do that? So this can be achieved by defining a custom function that can be called from within our XPath. The first thing that we want to do when defining a custom function is define a namespace. In order to distinguish our custom functions from the ones that are already default in XSLT or XPath, it's best to distinguish those based on a namespace. And therefore, in our very first line, our XSL style sheet, we define a new namespace, XML namespace. We'll call it SS for Suite Solutions, and we give it some identifying string, in this case, the URL of our company. We now have a namespace called SS, and we can use that to identify our custom functions. The first custom function that we'll define we'll call first uppercase. So you can see that we define it almost in the same way that we would define a template, XSL function instead of XSL template. It has a name just as a template can have a name. In this case, it starts off with our namespace, colon, whatever name we want to give it. The namespace also prevents it from potentially conflicting with similarly named functions in other namespaces. And again, just as in a template, just as we could do in a template, we define a parameter, in this case, string. And what this custom function does is it returns the value of the following select statement. The select statement calls another function, concat, which concatenates two strings. And the two strings that it concatenates are the uppercase of, the uppercase version of a substring of the string starting with the first character and continuing on one character. In other words, we take the first character of the string and we convert it to uppercase, and then we take a substring starting from the second character and continuing towards the end of that string. We take that and we convert all of it to lowercase. These two functions that you see here, upper dash case and lower dash case, are actually new to XPath XSLT 2.0. They weren't there in XPath 1.0. There were other ways to achieve the same goal in XPath 1.0, but these new built-in ones are actually very comprehensive in terms of different alphabets, different character sets. They work not only on the Latin alphabet, but as well on the Greek alphabet, the Russian alphabet, and others as well. So they're certainly very useful to have around. So first we define sort of a helper method, a secondary function called first uppercase, which takes any string and capitalizes the first letter of that string and lowercases all the following letters of that string. Moving on, we then define our real function, SS colon title dash case, which again takes in a string and does the following. This is a recursive function. I hope you're familiar with the concept of recursive functions because it can be pretty confusing to try to explain for the first time. But the recursive function has two cases, two possibilities. Either the string that we've been given has a space in it, or it doesn't have a space in it. Let's actually start with the second one here. If it doesn't have a space in it, then we simply call our method, and this is how you do that. SS colon first uppercase string. If there's no space in our string, then we just have to capitalize the first letter, lowercase the rest, and return that value, and we're done. If there is a space in the string, then we need to be a little bit more complex. What we need to do is concatenate the first uppercase version of the substring before the space, i.e. the first word, followed by a space, followed by the title case of the substring after the space. What this does is it gives us the first uppercase version of the first word and then continues on to process the rest of the string. So if there are 5 more words, we'll continue to process each of those recursively. We'll capitalize the first word and then get the title case version of the rest of it. The title case version of the rest of it will capitalize the second word and get the title case version of the rest of it, which will capitalize the third word and get the title case version of the rest of it, which will capitalize the fourth word, and so on. So recursively, we'll go through processing each word one by one, capitalizing each word one by one, and then moving on to the rest of the string. This recursive function will eventually, after processing the entire string, give us the title case version of the original string that had been passed in, capitalizing the first letter of each word and lowercasing the rest of it. And how we then call that, there really should be more of a space here because this value of is not really part of the function, but this is an example of how we would call that. Anywhere within our XSL, we could take perhaps the title of our current topic or whatever string it is that we want to convert to title case and simply say that we want to get the value of the selection when we pass our string to convert into our new custom function, ss::title case. And this will return a title case version of our string to convert. So the truth is this didn't really use much in the way of axes and node selection as we've seen, but by combining some other XPath methods, which again are really intertwined with XSLT, putting those all together, we've been able to devise a pretty sophisticated, at least for XSL, certainly nothing by C++ or Java standards, but for XSL this is pretty sophisticated processing to be able to recursively title case, convert to title case a string of any length. This obviously doesn't deal with new lines and tabs and so on, but it's simply as a proof of concept, and certainly if the client's data matches these patterns, this shows us some of the power of XPath. Moving on to our next example, let's talk a little about the new Tokenize method function. The goal here is that a client wants to check for a particular output class, in this case we'll call it border, among many. And the challenge is that we can't simply check for equals because in the output class attribute, a little bit of background for those of you who may not know, the output class attribute is similar to a class attribute in HTML. The authors can set certain values to the output class that will help to indicate to the custom DIT processing how that particular element should be processed. So for example, you may sometimes want an ordered list to show up and look like a table, be processed like a table. You can, on your ordered list, you can say output class equals table, and the custom DIT processing will be able to see that output class and process it accordingly. In this case, there's a border attribute value, but the problem is, the challenge is, that the output class can contain a number of space-delimited values. So we may have some other values, and therefore the output class may be set to border space other, or other space border, or other A space border space other B, and therefore we can't simply test that the output class is equal to border because there may be other values in there. And we also can't test that the output class contains border because there may be another value, such as borderless, which means the exact opposite or means something different, which also contains the same text. So we want to test specifically whether there is the word border within the output class, either with a space before or a space after, or no spaces before, no spaces after. How do we do that? So the old way of doing that, before XPath 2.0, in XPath 2.1, we would really have to test for all the particular cases individually. And that's the solution one that you see here. If the output class is equal to border, or the output class starts with border space. It might be a little hard to see, but there is a space after the word border here. So if it starts with border and then there's a space and some other stuff that we don't care about, the problem is in XPath 1.0 there's a starts with method function. There's no ends with function. So to see if it ends with space border, what we need to do here, and I'm skipping this third one here, there's the only way to see if the string if the output class ends with the word border, the self-contained word border, is to find the substring of the output class, starting a certain number of characters before the end of that output class attribute and moving forward till the end, and see whether that matches space border. So we look at the substring starting back, 6 characters back, look towards the end and see if the end of the output class is space border. And then the middle case here is that it contains the text space border space. Again, the self-contained word border. And if that's the case, then in this particular example, we want to apply the attribute, the border attribute of 1 point solid black border. It works. It's certainly feasible. It's a little clumsy. We just want to see whether the word border is in there, and we have to deal with 4 different cases, each individually. Fortunately, starting with XPath 2.0, there is a better way to do it. That's what you see in front of you now. That uses the Tokenize method. Tokenize is a common concept in programming. You may be familiar with it from other languages. And it essentially splits a string up into a number of smaller strings using a given character or characters as a delimiter, as something that is meant to divide between those strings. So what we do here in XPath 2.0, we can call the Tokenize method, passing in our entire output class attribute and indicating that we want to tokenize it with a space. And therefore, if we have 15 different values in our output class, which is probably a bit much. If you have 15 different values in your output class, you may want to reevaluate how you're designing things. But as many as we may have, it will split them all up and give us, if we have 3, in our case of other A space border space other B, it will return to us an array of 3 elements, other A, border, and other B. So this Tokenize method returns an array. And then what we want to do is we want to find within the results of that, and here we get back to a predicate that you may recognize the format of from before. We tokenize it, we get back an array, and we want to find the member of that array for which it is the case that dot, you may recall, refers to the self, dot meaning the current value, the value of that current node, of that current value is equal to border. So if it is the case that when we tokenize output class using spaces as a delimiter, it is the case for one of those values that that value is equal to border, then we apply the attribute, the border attribute of 1 point solid black. This achieves the same results that we saw before, but it's obviously a lot simpler and a lot more versatile. At the very least, you don't need to worry about the length of your string. If we were to, remove the R, change it to board, or use this method 15 different times, you don't need to count the number of letters and start the end of your last string from then, as we did over here. You can simply check to see if any of the values separated by spaces are equal to your desired output class. And that's a way the Tokenize method can help us simplify our XPath significantly, dramatically. There are a number of different functions that are available in XPath and XPath 2.0. We're not really going to go into them anymore right now, but hopefully this gave you a taste of what's possible. And again, if you refer to those reference pages, you'll see some more of the functions that are available. We're going to move on now to a topic that I referred to before, keys. We spoke about the trademark example. But let's get back to a slightly more refined goal. The goal is still that the client wants the trademark symbol to appear only on the first usage of each trademark. But in this case, the client is a little bit more specific about performance requirements. The client doesn't want to take the performance hit of searching through the entire document each and every time a TM is processed. As we saw before, every time you process a TM, you're going to have to look through, okay, maybe not the entire document, but all of the preceding documents to see whether there was a previous TM element that had the same trademark attribute. That obviously can take a performance hit. Everything is relative. There's a lot going on in XPath, and we're not talking about adding half an hour to your processing necessarily, but if you have enough trademark elements and your publication is big enough, and you do that for a number of different types of techniques or requirements, it can really start to add up. Using keys, we can avoid doing that. Keys are exactly what they sound like in a programming language. They basically provide an index of a particular element or set of elements with particular values as the key. In this particular case, we first define using XSLT a key whose name is TM for trademark. We want that key to match any element for which it is the case that the class attribute of that element contains the text topic/TM, i.e. any trademark element. And we're going to use as the key for all of those elements that we're indexing the trademark attribute. I'll just give you a second to process. Essentially what we're doing here is we're creating an index of all the TM elements using each individual TM element's trademark attribute as the key to that element, or those elements. Right? Given that the trademark attribute can appear a number of times, there may be one key with a number of matching elements. Let's say there are 15 different TM elements that have the same trademark. So there are going to be 15 different TM elements under that particular trademark attribute as the key. And then instead of what we had before, where we looked at all the preceding elements and saw if there was any one that had the same trademark element, what we can do instead is what you see right in front of you right now. If, I'll get back to the generate ID function in a second, but for now, what we're essentially saying here is if the current element, the dot, is equal to, and then we retrieve the key method that you see here, calling key, retrieves the values from that particular key. So we call the key function, and we give it the name of the key that we want to use. This TM here matches the name that we defined in the XSL key element. And we pass in the value that we want to search for, specifically the trademark of the current TM. So we go back to our key, we go back to our index, and we say, give me all of the elements that we indexed before that match a particular key value, specifically the current trademark. As I mentioned before, that key will return a number of different elements, perhaps 15. And therefore, we want to see which one of those is first. They're kept in order based on the order in the document. So we get the first one, and that's what the little predicate here of a 1 means. It means that of the entire array that we get back, get the first element that matches it. So essentially what we're doing is we're checking to see whether the current TM element is equal to the first TM element that is keyed by this particular trademark value. Now, to get back to the generate ID aspect here, you can't really directly compare nodes. But what you can do is directly compare the unique IDs that can be generated from those. The generate ID method function generates a unique ID for any particular node based on a number of different factors. And therefore, no two nodes, theoretically, within your document will have the same uniquely generated ID. So we check to see whether the unique ID that gets generated for the current node is equal to the unique ID that gets generated for the first TM node with this trademark attribute. If those two unique IDs are the same, then that must mean that they're the same element. And therefore, we know that we are currently on the first TM element with that trademark attribute. Again, just to review, it's a bit confusing. We create an index of all TM elements based on their trademark attributes. And then when we hit any particular TM element, we retrieve the list of all TM elements that have that particular trademark attribute, that are keyed by, that are indexed by that trademark attribute, and we check to see whether this one is the same as, is equal to, the first of those. If it is, then we're going to continue processing. We're going to insert our symbol. If it isn't, then we won't. If it isn't, then we'll leave out our symbol. So because we use the keys, because we use the indexing here, the performance is going to greatly increase. Again, it's all relative. This is a small part of our processing, and it obviously depends on the size of your document. But this is a good example of how keys can work to help you identify all elements within a document or quickly identify all elements within a document or within a particular space of a document that match certain criteria. For our final example, we're going to discuss a more complex topic of grouping, and we'll see two ways that you can group different elements within your processing. The example that we're going to deal with here is that a client wants to group all child links by type. Within a document, and this is less common for PDF processing, but certainly in HTML processing, you'll often have links to child topics, i.e. within a parent topic, you'll say, now the subtopics of this are A, B, and C. In this particular case, the client wants to group the child topics by type. Specifically, they want task child topics to be distinct from reference child topics, to be distinct from concept child topics, and whatever else may be present. In this particular case, I'm showing you a small sample of the stage1.xml file. This is a link pool that's showing us all the child topics. I've trimmed out some of the extraneous XML just so it doesn't distract us here. But you'll see here that we have 3 links with the role of child. 2 of them are concept, of type concept, the first and the third. And then 1 of them is a reference, the second one. So in this particular case, the client would want to process all 3 of those, but keep the 2 concepts together and the reference separate. How do we do that? The first way to do that is using something called the Munchian method, and it uses keys just like what we just saw. Obviously, in order to create a grouped listing, there are 2 things we need to be able to do. First, we need to be able to figure out which group values are present. In the example that we're looking at, that there are concepts and there are references. We don't want to bother trying to process tasks, and we need to be able to dynamically figure out that there are concepts and references. Once we know that there are concepts and references, we need to know which links are concepts, which links fit into that first group, and then which links are references, which links fit into the second group. So we'll do this again using keys. I've simplified things here a bit. The scope of an XSL key is actually your entire document. So if you were dealing with PDF, then this XSL key would really give you all of your child links throughout the entire document, whereas we're presumably limiting ourselves to a particular topic. But I didn't want things to get too complex here, so I've left out that detail. Or we can assume that we're dealing with HTML, where really there's only 1 group of child links. What we do here is we define, again, a key whose name is child links, and we want that to match any element whose class attribute contains the text topic/link, i.e. it is a link, and its role attribute is equal to child. So in the XML that we're looking at here, that's going to match these 3 link elements because they all have a role of child. And we are going to key those by their type attribute. We're going to use as the key the type attribute of each link, whether that be reference, concept, or task. That's the key that we create. When it comes time to use that key for grouping, we do it as follows. We have an XSL for each, which goes through each element in the selected set of elements. So for each element in the set of elements where we're matching any element whose class contains topic link and the role is a child. And it is the case, and it also is the case. You can have 2 predicates, one after the other, as you see here. And it also is the case that the current link is equal to the first link with that type. Right here we're using a technique similar, this generate ID technique is similar to what we did before with TMs. We are checking to see whether the current link is the first link with that type attribute. If we have 15 different concept child links, we want to look only at the first one for now. And that will essentially give us the first concept link, the first reference link, and the first task link. And in that way, we can achieve our first goal of figuring out what our distinct groups are. Right? Because what we're saying is that for each link, if that link is the first one of its type, then we know that we have just encountered a new group. I should be more specific. For each child link, if that child link is the first one of its type, then we know that we've just encountered a new group. So as we cycle through all the child links, when we hit the first reference, we're going to see that this is the first child link with a type of reference. Just as we saw previously in the TMs, we saw that this was the first TM with its particular trademark attribute. So to here, we're finding each child link that is the first child link with its particular type attribute. And then we're going to create just a simple little heading in an FO block, which already gets us onto XSLFO, which we're not discussing now either. For each of those first links of their type, we're going to create a heading. We're going to take the value of, made use of our custom function from before. We're going to take that type attribute, we're going to capitalize it, and we're going to make that our heading. In this way, anytime we encounter a link that is the first of its type, we're going to create a heading for that type. So we hit the first reference child link, we put in the heading, reference, capital R. What we then do, we've just hit our first reference topic, is we then get all of our child links that are of type reference. Right here we're retrieving from our child links key all keyed items that have that type, that have that type attribute as their value, that type value as their type attribute. So when we hit the first reference child link, we're going to create a reference header and then retrieve all reference child links and process them however we want to, creating links, creating a list, whatever the case may be. As we then continue on, we're not going to do anything for the rest of our reference child links because we've already processed all of our reference child links here. But when we hit our first concept child link, we're going to create a concept header, and then we're going to retrieve all of our child links that are of type concept and process them. And then when we hit our first task child link, we're going to create a task header and then process each of them, going on to process each child link that is of type task, that has task as its type attribute. So this is a way to use keys for something more complex, grouping. If you look in some of the default DITA-OT code, this is in fact done for HTML already in a slightly different manner, but it's the same concept. And this is one way, this is the XSLT 1.0 method of doing things. It's called the Munchian method. It was devised by, I believe, a programmer or a theorist named Steve Munch, I believe. He came up with this way of doing things. So that's one way to use XPath, to use keys specifically to group elements in your DITA-OT output. A more advanced, yet slightly simpler way, as you might have guessed, comes in XPath 2.0. XPath 2.0 adds, and XSLT 2.0 adds some new elements and some new custom functions, not custom functions, new default functions that allow us to do this in a much easier way. Because as we just saw that there's an XSL for each in XSLT 1.0, in XSLT 2.0, there is an XSL for each group element. And what that does is basically what our key did in the previous example, the previous solution. Rather than cycling through each element, it cycles through each group of a particular set of elements when those elements are grouped by a particular value. So what we do here, you'll see the syntax is almost very similar to what we were doing before. The structure is very similar to what we were doing before, yet the syntax changes. We call an XSL for each group. The elements that we want to group together are the same as before, are links that have a role of child. And we specify this new attribute here, group by type. And what that will do is it will give us the groups of elements, the elements grouped by their type attribute. For our heading, we then have the same structure, except instead of calling the type, instead of passing in the type attribute of the current element, we don't have a current element. We have a current group of elements. And therefore, we need to get the current grouping key, which is the key of the current group. So as we go through each group, we'll have, in our particular XML example, we'll have two groups, concept and reference. Task might be in there also. So for each of those groups, task, concept, and reference, we'll go through this for each group loop here, and each time we'll have a current grouping key, which will be the value that we're currently grouped by, the type attribute of all of the current set of elements in the current group. So the current grouping key will be either task, concept, or reference. And then we want to process all the elements in the current group. And that goes back to the old XSL for each element, but it uses the new built-in function of current group. That returns all the elements in the current group. So the structure here is the same. We're essentially cycling through the larger loop for each group and then the smaller group for each element in that group, but we're using the new XSLT 2.0 and XPath 2.0 functionality in order to achieve that. Because here we can very easily simply cycle through for each group. We have 3 groups. For each group of those 3 groups, we first output our header, and then we go through all the elements that are in that current group, all of our reference child links, all of our concept child links, all of our task child links, and we process those accordingly. There are ways to sort this. I didn't get into the XSL sort element. That's really more XSLT than it is XPath, but you could choose to make sure that that your concept comes before your reference, which comes before your task, alphabetically sorted in that way, or sorted by whatever other means you want. That is possible, but here at least we see that the grouping technology, the grouping methodology, is a lot simpler in XPath 2.0 and XSLT 2.0 than it was in XSLT 1.0, where we had to make use of the keys. It was still possible, but it does become a lot simpler when we have more advanced methods available to us. That concludes our last example. Just a quick overview of what we saw. We spoke about exactly what XPath is, and it's the XML path language, which is used to navigate or search throughout our entire XML tree, various nodes. We started off with some of the basics, some of the foundations of XPath and XSLT with axes, node selection, and predicate. And then we moved on through increasingly sophisticated examples. The list numbering that was simply selection, looking at the ancestors. Trademark, which looked at all the preceding nodes and made use of the current function. We defined some custom functions in order to allow a client to convert certain strings into title case. We looked at the Tokenize function in order to allow a client to match a particular output class within a set of output classes. We revisited Trademark by using keys to search for the first TM element that had a particular trademark attribute. And finally, we got to our most complex example, grouping, which we did first using keys and then using the new XSLT 2.0 functionality of XSL for each group. I hope you followed it all. If you didn't, please be in touch. Again, my name is Ruben Weiser. My email is listed right there, rubenw@sweet-sol.com. I'll be happy to answer any questions you might have about XPath or XSLT. And anything beyond that, we're happy to help if we can. Again, we specialize in style sheet development, one-on-one support and training, or for your entire organization, online or on-site. CMS integration with a number of the different CMSs, certainly the most popular ones. And we have a lot of experience. We have a very good, strong team that can really help with any of your needs, conversion, document conversion. So please be in touch with us about any questions you might have, whether they be related to XPath or XSLT or anything else. I hope you enjoyed the webinar. I hope you understood the webinar, but please be in touch with any questions. Thank you, and have a good day.